Hi students, this is Mrs. Turner. I'm sorry I am not there today, but like I mentioned last class, I'm not going to be here today. I'm currently at home with plumbers who are tearing up my yard and replacing all of our pipes due to a plumbing issue we had last weekend. So hopefully you're having a good day, but I want us to continue our study on parallel lines and transversals. So in the last section, you were introduced to parallel lines and you learned about transversals. So for example, if I draw two lines that are parallel, we learned that there are two lines that never intersect, and we can indicate that by the two little arrows on the lines, right? And then we also talked about transversals. So if you have one line that intersects two lines, then you create two different intersections, and then you end up with 8 different angles. So you have one intersection, angles 1, 2, 3, 4, another intersection, angles 5, 6, 7, 8. Okay, and here's your transversal. So it's that one line that goes through two other lines, creating those 8 different angles. And we talked about different pairs of angles. We talked about corresponding angles, alternate interior, alternate exterior, and same side interior. So now we're going to kind of put these two ideas together and look at what if the two lines are parallel. What are we going to see about these different types of angles? So on your notes, the very first thing that you have there is the corresponding angles postulate. And if you remember, postulate is what? Okay, so it says corresponding angles postulate. Postulate is a statement that we accept to be true without proof. So it's something that's true no matter what, no need to prove it. And so here's what it says. It says if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So you want to write that down in your notes. Corresponding angles are congruent. And the important thing to point out here is it's if you have two parallel lines, then the corresponding angles are congruent. All right, so this video is going to stop in a second. It's going to have you answer these questions. Let's just get this out there. So in our diagram, right, we see these 3 lines, P, Q, and T. So I just mentioned this not too long ago, about a minute and a half ago. What markings do we look for to show that lines are parallel? Okay. So of those 3 lines, P, Q, and T, which 2 lines are parallel? And then which line is the transversal? All right, hopefully you said that the 2 arrows are the symbols that indicate which 2 lines are parallel to each other, right? So the 2 little arrows there, so it indicates that line P is parallel to line Q. And then the transversal is T. It's the line that intersects both of those lines. So according to this postulate, it says that corresponding angles are congruent. So if you remember our corresponding angles, we think of angles that are in the same position. So angle 1 and angle 3 are both in that top left position. So those are a pair of congruent angles. Okay? Same thing with angles 5 and 7. So those are both in the same position. They're both in the bottom left. So they are corresponding and they are congruent. What do we have to do? 2 and 4. Okay, those are both in the top right. Okay, both above the transversal, above line T, and to the right of P and Q. And then 6 and 8 are the other pair of corresponding angles. They're both in that bottom right. They're both below T and to the right of P and Q. So they are congruent. Okay, so that's the corresponding angles postulate. All right, so let's look at an example with some actual measurements here. So here first, before we do anything and answer anything, let's just kind of take a look at our diagram. So we have two lines that are parallel, right? We can indicate that by these two little arrows. Okay, with the two little carrots, or they look like greater than symbols. So those are our parallel lines, and then this other line, AB, is the transversal. All right, so let's look to see what we have as far as other angles here. So we have an 80-degree angle and an X degree angle. So notice that they're both in the same position. Okay, this angle, 80 degrees, is in to the right of the transversal, and it's kind of above or to the left of this first parallel line. And then same thing with X degrees. It's to the right of the transversal, and it's above or to the left, however you're looking at this, to this line. So they're in the same corresponding position, so they're corresponding angles. So by the corresponding angles postulate, they are congruent. So anytime you see parallel lines and transversals now, you're going to automatically think corresponding angles. If you see them, mark them congruent. So then what does congruent mean? It means they're equal. So 80 would equal X. And because we're looking for the measure of angle ABC, which is X degrees, then measure of angle ABC is also 80 degrees. Okay? And if you look at this for a second here, let me erase my markings. If you think about here, if we look at this line with BC, kind of look at the intersection here of the transversal, we get this angle X, which is 80 degrees. Should be able, let's see if I can pick this. Nope, this isn't gonna work. Let me just, hang on 1 second. All right, let me go back and I'll just do the congruent mark. So from there to there. So if you think about the parallel lines and this intersection, it's almost like it's an exact duplicate, or not almost, it is an exact copy from one to the other. So if you imagine just like literally cutting this out and going up here, you're going to get the exact same angles. Okay, so that's why they're both 80 degrees. All right, let's look at another example. All right, so again, we have a set of parallel lines. You can see that with the symbol. And then DE is the transversal. And so we can mark any pair of congruent angle or corresponding angles congruent. So notice the two angles that were given, 2x minus 45, x plus 30. Those are both in the same spot. They're both in that top right. So they are corresponding. So therefore they are congruent, which means we could set them equal to each other. So I get 2x minus 45 equals x plus 30. And the reason why we want to do that is because we're trying to find the measure of angle DEF, which is x plus 30. So in order to do that, we need to know what x is. So here we have an equation. We can solve for x. So I'm going to subtract x from both sides. And then add 45. So we get x equals 75. And then be careful, don't just stop and circle that as your answer. Make sure we're actually answering the question here, which is what's the measure of angle DEF? So then I need to take what I just found for x and plug it in. So 75 goes in for x, 75 plus 30 is 105 degrees. So measure of angle DEF is 105 degrees. All right. Then from the corresponding angles postulate, which again, remember, a postulate is something that we accept without proof, we can then actually use that idea to come up with these next three theorems, which are then going to give us some information about those other three pairs of angles: the alternate interior, alternate exterior, and same side interior. Okay, so alternate interior angle theorem. It states that if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Again, if you need to pause, write all this down, press play when you're ready. So if I'm over here looking at my diagram, right, I see these two lines are parallel, got my transversal going through. So 1 and 3, those are alternate interior, so they are congruent. And then 2 and 4 are the other pair of alternate interior angles. So the conclusion that we can make about them is that they are congruent. And the nice thing about your notes here and what you're seeing on your screen are looking at the different colors. So you have you have red and blue angles that are pairing up which ones are congruent. So the two red angles, 1 and 3, those are one pair of alternate interior, and then the two blue angles, 2 and 4, are the other pair. All right, same thing about alternate exterior angles. So that theorem says that if two parallel lines are cut by a transversal, then the two pairs of alternate exterior angles are congruent. So if we look at that diagram, we have angles 5, 6, 7, 8. Those are the 4 exterior angles. And we have 5 and 7 are alternate, so they are congruent to each other. And then 6 and 8 are the other pair of alternate exterior angles, so they are congruent to each other. Now the last pair are same side interior, and these ones are different. So we've kind of been on this, having a trend here of angles being congruent, but same side interior angles are different. So this theorem states that if two parallel lines are cut by a transversal, then the two pairs of same side interior angles are supplementary. Okay, so again, if we're looking at our diagram here, angles 1, 2, 3, and 4 are the 4 interior angles. So if we look here at the same side interior angles, so purple here, we have 1 and 4 are one pair. So then the theorem states that they are supplementary, or that they add up to 180. And then the other pair, 2 and 3, they are also supplementary. So angle 2 plus angle 3 adds up to 180. Okay, so just kind of be careful. We've got congruent, and then we also have supplementary. So we have alternate interior angles are congruent, alternate exterior angles are congruent, and then same side interior angles are supplementary. So that one's just a little bit different, okay? But the one thing to point out and just to kind of constantly remind you of is this is only happening when you have parallel lines cut by a transversal, okay? So let's just stop for a second and talk about that. So put your pencils down. I just want you to look up here and think about that for a second. So in the last lesson, remember when we talked about transversals to begin with, we were really kind of looking at a lot of diagrams that looked like this here to the right, where you had these two lines that were not necessarily parallel, and then they're cut by a transversal. So now look over here and see what the difference is. Now we're taking these two lines, straightening them out, and making them parallel. So that's what's creating these duplicate angles, right? So this intersection of these 4 angles is going to be exactly the same as the intersection of those 4 angles. Okay. And again, let me try to kind of highlight that again. So if we have, and actually, let's see, yeah, let me just highlight. So if we look at any one of these angles over here, let's look at this one on this side here, right? So if I take that angle, move it up the transversal, notice it's going to fit exactly in that same spot up there, which is the corresponding angle. So if it's the exact same angle, then they are congruent, okay? And then the same thing would work if I move it up and, whoops, it's not going to work. Let's see. I'm going to flip this. If I flip it, I got to flip it a little bit more. Nope, it's not going to work. I'm trying to rotate this. Maybe I can just rotate without making it a different size. There we go. If I move it up and rotate it around to get it to be the alternate interior, notice how, again, it's also going to fit. So this angle here, and then its alternate interior angle down here. There we go. They're exactly the same, okay? But when we looked at it before, so let's go over here to the right, when we looked at it in the last lesson, we didn't have those parallel lines. So your angle measures can be all 8 angles could all be different measures. So not necessarily the same. So if we look at that top left angle again, well, if we slide it down the transversal and find its corresponding angle, notice how it doesn't fit perfectly. Okay, it's probably even more obvious on the other side of the transversal. So let's look at this. Let me start over here and trace. So let's look at that top right angle. All right, so here's that top right angle. So now if we take that, slide it down, see how this bottom angle is bigger than that top right angle? Okay, so they're not congruent. They're still corresponding. Okay, so they're still in the same position. So we can still classify them by the name. So we still have corresponding angles. We still have alternate interior, alternate exterior. Okay, so here's, this angle here and this angle here, alternate exterior. We still have same side interior, so that angle and that angle. We just can't make the conclusions that they're congruent or supplementary. Okay, so moral of the story, kind of long story short here, is corresponding angles postulate and those 3 other theorems, the alternate interior, alternate exterior, same side interior theorems, only work with parallel lines. Okay, so that's really, really important to remember. Because a lot of times you'll be doing so many problems with parallel lines and setting things equal or adding them up to 180. And then if you throw in a diagram like this one on the right where there's no parallel lines, you might get a little kind of tricked there and set something equal that's not. All right, let's move along. Oh, a proof, I know. So last chapter was really kind of our heavy chapter on proofs. And for the most part, I mean, we are kind of done with it in that sense, but we are going to continue to prove things throughout the year. So we're going to continue to kind of see some proofs here and there. A little bit kind of heavier in this chapter, a little bit with proving, some things about parallel lines. But just kind of, again, keep practicing, and the more we see, the better we'll get. So what we're going to just do here is just look at one quick little proof that actually proves the alternate interior angles theorem. And remember, you can't prove a theorem by using that theorem. So we can't use the alternate interior angles theorem in our proof. That would be like if you use, if you're trying to define a word with the word in it, right? You can't use that word in its definition because the whole point is to explain what that word means. So in this diagram, we are given that L and M are parallel. Get my pen here. So we are given L and M are parallel, and we want to prove that angle 2 is congruent to angle 3. Okay, that's one of our pairs of alternate interior angles. So in our proof here, we have our statements. First reason is given. Next statement is that angle 1 is congruent to 3. Okay, so if you look at our diagram, notice angle 1 and 3, those are corresponding angles. And why are corresponding angles congruent? Well, that's because of the corresponding angles postulate. And remember, postulate is something true that we accept to be true without proof, and we can use that as reasons in proofs. So we can actually, we're going to be using that postulate to prove those other theorems. So that's 1 and 3 are congruent because of the corresponding angles postulate. And then we're also given that angle 1 is congruent to angle 2. And if you look up at line L, those are vertical angles. And if you remember, we have the vertical angle theorem that states that vertical angles are congruent. And then, how do we then get 2 and 3 congruent? We can kind of see from the diagram, right? So if 1 and 3 are congruent, but 1 and 2 are congruent, well, notice all 3 of them are congruent, right? So we end up having angle 1 congruent to angle 3, but angle 1 is also congruent to angle 2. So therefore, we can say that angle 2 and angle 3 are congruent. And why is that? That is substitution. So we're taking our corresponding angles 1 and 3, and we're basically taking out the 1, swapping in the 2, because 1 and 2 are congruent. So that's substitution. Okay, so there you go. All right, let's do some work now with some of those theorems. So in this diagram, it says to find the measure of the given angle, justify your answer by stating the theorem that you use. Okay, so we've got 2 lines that are parallel, and then this line AF is the transversal. So we've got angles 125, and we have an angle down here, x degrees. So if you notice their relationship there, they are alternate exterior angles. And by the alternate exterior angle theorem, it states that they are congruent. So if angle ABC is 125 degrees, then angle EDF is also 125 degrees. Okay, so measure of angle FDE, same thing as EDF, is 125 degrees, and that is because of the alternate exterior, the alternate exterior angles theorem. Okay. All right, how about the next one? So let's again, we identify we have 2 parallel lines. We have SU is the transversal, and we have an angle here, 13x degrees, an angle over here at vertex U, 23x degrees. And notice by their position, they are same side interior angles, which means they are supplementary. Okay, that's the one that's not like the other. The way I remember it is same side, I think S, they start with the letter S. Supplementary starts with S. Okay, so same side interior angles are supplementary, which means that they add up to 180. So my equation would now be 13x plus 23x equals 180. So then if I combine my x's, I get 36x equals 180. divide by 36, get x equals 5. Okay, but if you notice on your paper, it doesn't want x. We want to know what is the measure of angle TUS. So we had to find x in order to find the angle measure because angle TUS is 23x. So we'll plug in a 5 in for x. So we get measure of angle TUS is 115 degrees. And the theorem that we use is the same side interior angles theorem. Okay. All right, moving right along. Right, here we have a diagram, and it shows the treble strings of a grand piano. And so the 3 lines there representing those treble strings, they are parallel. You can see that by the little symbol there. So all 3 lines are parallel. And then viewed from above, it says the bass strings form transversals to the treble strings. So there's these 2 blue lines that are the bass strings. And notice they're not parallel. And you can kind of see that because if you imagine the arrows extending, they're going to intersect somewhere over here. You got this bottom line is slowly getting closer and closer to the top line. All right, so the way we can think about this is almost as if we've got 2 different transversals. And so we kind of have to identify which transversal are we looking at and which parallel lines. So let's first just kind of match up some of our angles. So we have over here the 25x plus 5y forms this angle up here. And if we follow along that blue line, we have 125 degrees down here. So if we just ignore for a second, actually, I'm going to cover up. Oops. We just cover up that bottom line. So just ignore that bottom line for right now. We could even ignore this middle green line. You see how we have our parallel lines and then that transversal? So we've got 125 degrees and the 25x plus 5y. See how those are alternate exterior angles. And again, if it's helpful to kind of rotate your paper around, if you like to see it from a different angle, different perspective, but those are alternate exterior, which means they're equal to each other. All right, let me bring those lines back. So my equation that I can set up is 125. Actually, you know what? I'm going to rewrite this. I'm going to put my variables on the left. So we have 25x plus 5y equals 125. I have x and y. All right, let's hang on for a second. All right, and next to that, I'm just going to put a note. Those are alternate exterior angles, which are congruent. All right, then let's take a look at our other angles that we have. So notice we have in this middle green line, we have a 120-degree angle. And then on the right green line, we have a 25x plus 4y degree angle. So now on this one, let's just for a second, we can ignore now this whole left green line we don't need. And then the top blue line, let's just ignore that for a second. So if we just focus on this bottom blue line is the transversal. And if you look at these 2 angles, you'll notice they are corresponding. They're in the same position. They're both in this bottom right position. So corresponding angles are congruent. So that means I can set up the equation 25x plus 4y equals 120. Okay, so those are because corresponding angles are congruent. So now, how do we solve for x and y? Because we have 2 variables. Well, if you remember back in Algebra 1, you spent probably quite a bit of time studying systems of equations, and you would solve two equations like this with two variables, and you either graphed them or you use substitution or elimination. So if you need to refresh your memory on that, I would highly suggest digging out your old algebra notes or doing a quick Google search and looking up a video, or I'm happy to kind of help you through that. But for now, I'm just going to kind of go through and I'm going to use elimination, okay? Because I noticed my x's have the same coefficient. And if you remember with elimination, the goal is to eliminate one of your variables. So I am going to take my second equation. First, I'm going to multiply everything by a -1. So I'm just going to I'm going to rewrite my first equation. And then underneath that, I'm going to rewrite my second equation, but now I'm going to multiply everything by a -1. Because then if I add these two together, so if I just go straight up and down and add my x's, they eliminate. And then 5 minus 4y is y. And then 125 minus 120 is 5. So my y equals 5. Then what you do is you go back to either one of these equations. So either the first equation or the second equation. And you're going to plug 5 back in. So I'm going to go back to my first equation, plug 5 in for y, and then you solve for x. So 25x plus 25 equals 125. Subtract 25 from both sides. Oops. Oh no, I didn't want to erase all that. Let's see. 25x equals 100. Divide both sides by 25, and I get x equals 4. So x equals 4, y equals 5 is my answer. All right. Whoops. All right, last one here. Kind of get you set up, and then I want you to try this one on your own. If you remember elimination from last year. If not, that's okay. I'm going to work through it as well. So here we have in the picture, it says the railing of a wheelchair ramp is parallel to the ramp. Okay, so the railing is this top line, and that is parallel to the actual ramp itself, which is on the bottom. And if you notice, there's these two posts that are creating those transversals. So I'm actually going to just recopy it in my blank space down here, just to get rid of all the extra pictures that we have. So we've got one rail, two rails, and we have 4x plus 6y is that angle, 86 is that angle, and over here 5x plus 6y, and then 94. So if we think about our angle relationships, we should notice that this 4x plus 6y and 86, those are alternate interior angles, so they're congruent. And then we have another pair over here, 5x plus 6y and 94 are alternate interior, so they are congruent. So just like in the last one, we can set up our two equations. So my first one, I could say 4x plus 6y equals 86. And then 5x plus 6y equals 94. So if you're feeling up to it, why don't you pause and see if you can finish solving the system. And I am going to kind of work through it myself. So just like I did in the last one, I recognize that my y's will eliminate nicely if I just multiply my second equation by -1. So if I bring over my first line, my first equation here, my second one would be negative 5x minus 6y equals negative 94. So then if I add together my x's, my y's, and my constants, 4 minus 5 is negative x. My y's eliminate. And then 86 minus 94 is negative 8. But I want to know what x equals, not negative x, so I need to divide both sides by negative 1. So I get x equals 8. And then once I know what x is, I can plug that back into either equation in the beginning and solve for y. So I'm going to go back to my first equation, plug in 8 in for x. So 4 times 8 is 32, plus 6y equals 86. Subtract 32 from both sides. So I get 6y equals 54. Divide both sides by 6, and then I get y equals 9. So my final answer, x equals 8, y equals 9. All right, and that finishes our notes for that section. So you're going to do some work with this in class and do some practice. And we'll talk about all this next class when I am back. But my recommendation is, again, just kind of go back over your notes, review these different pairs of angles, try to really start to understand and learn about when they are congruent, when they're supplementary. And then you might also want to refresh yourself on solving systems, because just because you're not in Algebra 1 anymore doesn't mean that we're not going to continue to use some of those skills that you learned last year. All right, I will see you next class.